Once again, you are asked to find the equation for a straight line, but in this case, for the perpendicular bisector of a straight line. Now we need to go back and think on what is perpendicular, people. Perpendicular means the lines meet at a 90-degree angle. And bisector means two equal parts, okay? So if you look at this one, if this is the perpendicular bisector of line AB, then we know, the facts we know is that there is a 90-degree angle between the two lines, but more importantly, the distance from A to the perpendicular bisector is equal than the distance from the perpendicular bisector to B. Okay, so this part is equal to that part. And when we now think further, then we realize that this cutting point actually forms the midpoint of line AB. And we already learned how to calculate the midpoint, okay? And remember, the midpoint is a coordinate, right? So when we now look at the example, we've got two coordinates. They are given here, right? They say find the equation of the perpendicular bisector of AB, and then write it in the format AX plus BY plus C, which is the standard form of a straight line graph, right? Remember, we got the gradient intercept form, which is y equals mx plus c, or we have the standard form, which is ax plus by plus c equals 0. Both are equations for straight lines. All right, so we must now take this very slowly, step by step. You are starting with two given coordinates. Now remember, in the previous example, where we were given two coordinates, we learned that the first thing we do is we calculate the gradient of the line of those two coordinates. And remember, the gradient is calculated by y change over x change. You substitute your y coordinates, you substitute your x coordinates, you then calculate, and in this case, line AB has a gradient of negative 5, 6. Right. Importantly, you must find the perpendicular bisector. Now, what we also know about perpendicular lines is that the two gradients multiplied will give us a product of negative 1. So, the gradient of the perpendicular bisector, okay, is where the two gradients must give me a negative 1. So the one that I have calculated is negative 5, 6, negative 5, 6. Then we multiply by the reciprocal, so that's 6 fifths, and the opposite sign. Okay, so that's negative, then this one must be positive. And if I multiply these two, I will get negative 1. So the gradient for the perpendicular bisector is 6 fifths. Right. Now the next important part is we realize that one of the coordinates, which is of line AB, as well as the perpendicular bisector, is where they actually intersect. And that intersecting point, remember, importantly, is the midpoint. So which means now we are going to first calculate the midpoint. And remember, in the previous video, I taught you that the midpoint, number one, important, is a coordinate. So it's in the format of x, y, okay? And secondly, I taught you it is always the average of your two x coordinates and the two y coordinates. So therefore, when we calculate the midpoint, we add x1 plus x2 and we divide it by 2. Okay, and for the y coordinate, we are going to add y1 and y2 and we divide that by 2. So once again, from your coordinate, choose your x coordinates, negative 3 and 9, divide that by 2, and your y coordinates, 6 and negative 4, 6 and negative 4. Divide that by 2. And if you now calculate that, you will get the coordinate of 3, 1. Now I want to go back to this drawing. Remember what we now have. We already have the gradient for the perpendicular bisector as well as the coordinate of its midpoint, which means we can go back to how we calculated the straight line graph if the gradient and one coordinate is given. So that we have done previously, and remember, we then start with y equals mx plus c, and we simply substitute the gradient, which is 6/5, and we also substitute the coordinate y and x. In the previous videos, we were doing that in separate steps. We started off by doing y equals, instead of m, we written 6/5 x plus c. That was step 1. Okay, substitute the value of m. Then in step 2, we substituted the value of the coordinates, so the y coordinate and the x coordinate, so that we can actually find c, which is then 3 and 3/5. Okay, and then lastly, we went off and we put our values into the standard form. We put the 6/5 x and the c into the standard form, and that is what your equation is. Right, so in this specific example, however, the last question says, write your answer in the form ax plus by plus c equals 0. So they don't want the gradient intercept method. Okay, they want it in the format of ax plus by plus c equals 0. Okay, now this is really just simply rewriting that very same thing that you have. Okay, have a look. We've got y equals 6/5 x minus negative 2 and 3/5 is in a improper fraction, negative 13/5. Okay, so let me just circle this and this and this comes from your gradient intercept format. Okay, now because this format ax plus by plus c may never be fractions, it must always be whole numbers. That you must remember, okay? In the standard form, a and b and c must be an integer, right? That you must just simply remember. And if we now look at this one, here we've got a fraction, there we've got a fraction, so it is no more integers, okay? Then we are going to use simple fractional knowledge. We've got 1 and 5 and 5, okay, as denominators. So we must now actually make them the same. So we're going to multiply each fraction by 5 over 1. 5 over 1, 5 over 1. That, the lowest common multiple of the two denominators, which is 5 and 1, is 5. And we learned that we multiply each fraction with the lowest common multiple. Okay, so 5 over 1, 5 over 1, 5 over 1. When you then calculate the left hand side, you get 5y. Here we can cancel the 5's. It gives me 6x minus, and here we can cancel the 5 again, which gives me 13. So now if you look at that, you've got whole numbers. Okay, so they are all integers, but it's not yet in the format of ax. Okay, this is ax, this is by, and this is c. So the standard format is ax that you write first. Now the by needs to be taken over. We want it on that side. So it becomes negative 5y, and then the c is negative 13, so it's already there. But because we have taken over the 5y, on the left-hand side, we've got a 0. So this basic part, people, changing from the gradient intercept form to the standard form. That is basic fractional knowledge, which you have done even under the whole numbers topic or the numbers topic. Okay, if you can't remember that, you must please go back in your textbooks and study that. That is how we actually get rid of the denominators, by multiplying with the lowest common multiple. Okay, and then from here to here really is just Goro's or, so that we get it into the format ax plus by plus c. All right, so shall I go through those steps again very quickly? Two coordinates are given. We must find the equation, okay? But we must find the equation of the perpendicular bisector. So in step 1, because we've got the two coordinates, we're going to calculate the gradient. From that gradient, people, we can find the gradient for the perpendicular bisector, which is the reciprocal fraction with an opposite sign. Okay, so it needs to be reversed around and it must be the opposite sign. With that, we find the gradient for the perpendicular bisector. Then we also realize that the bisector always crosses the midpoint. So second part here is to calculate the midpoint. The midpoint is calculated from averages of your x and your y coordinates, which are given in your A and B. Okay, and then thereafter you can just now simply go, you've got the gradient for the perpendicular bisector, you've got one of the coordinates, which is the midpoint for the perpendicular bisector. So gradient and one coordinate given, we are going to actually substitute m, the gradient. Then we will substitute x and y to calculate c, right? And from that, you find your value for c, meaning you can write that into y equals mx plus c, okay? Your calculated gradient goes in there, your calculated c value goes in there. Okay, and then in this specific case, because they ask you to write it in the format of ax plus by plus c, that is why you just need to rewrite, get rid of the fractions because it must be integers, doing it by doing Goro's or multiplying by the lowest common multiple, and with that you get your final answer, 6x minus 5y minus 13 equals 0.